Welcome to Homework Lib.
Hi, so for this question, we could consider two different approaches. First of all, applying Lambert-Beer's law in order to find the coefficient of extinction for our system, or the other one, since we are provided the data points, we can do a linear regression in Excel. So essentially, the values that we're going to put in X are the concentrations of sulfate in milligrams per liter. And what we're going to put in the y-axis is going to be the transmittance that you are measuring. So after we have done this, we can generate a linear trend and give the values. If you do this, the equation that we find is the following: minus 0.0203x plus 0.907, and the value for r squared, which tells us how good this trend is 0.9403. Okay, so in theory, it's not like a very, very good trend, but you could make it a little bit better by collecting that again, for example, right? So what we can do is, employing this, we know that the value for y that is given us by a sample is 0.538. So we simply need to solve for x, right? So coming from this equation, y minus 0.907 divided by minus 0.0203, it's going to be equal to x, which is the concentration of sulfate. We are going to substitute the value, in this case 0.538, that is the one that is provided to us, minus 0.907 divided by minus 0.0203. And this is going to give us the concentration in milligrams per liter. So after doing this operation, the result that we get is x equals 18.17 milligrams per liter. Let's check out if it makes sense. If you look at the table, the value for transmittance should be in between the concentrations of 10 and 20 milligrams per liter of sulfate. And that would be all for this problem. Thank you very much.